So this lesson is on the laws of exponents, simplifying some polynomials. And there are some rules that we need to go over. You've learned these in Algebra 1, we covered them in Algebra 2, and now we're going to review them again in Algebra 3. So if they are multiplying, the rule is that you add them. Let me give you an example. If I had 2 to the 4th times 2 to the 6th, you would leave your base the same, so it would stay a 2, and you would add your exponents. So 4 plus 6 is 10. If they're dividing, the rule is that you subtract them. So if I had x to the 10 over x squared, I would subtract them and get x to the 8. Negative exponents are not allowed. The way you fix a negative is to switch it. Here's what I mean. If I have a to the negative 2, b to the 3rd, and then c to the negative 5th. You cannot have the negative exponents. Positives are fine, negatives are not. So a to the negative 2, I would move it to the bottom, and it would become a positive. B to the 3rd is already a positive, so I would leave it on top. That doesn't change because it's already a positive. On bottom, I have c to the negative 5. Well, you can't have a negative, so I would move the c to the top. So again, the a to the negative 2 moved to the bottom so that it could become a positive. The c to the negative 5 moved to the top so that it could be a positive. And I just left the b on top because it's already a positive. Power to power means if you have this exponent on the outside, the rule is that you multiply it. So an example, if I had x to the 3rd to the 2nd, you would multiply. So that would be x to the 6th. The second one is it's pretty much the same. If it's on the outside, you multiply it to everything on the inside. So, for example, if I had x, y to the 3rd, all that squared, well, this x has a 1 there. If there's no exponent, you put a 1. And then you multiply. That would be x to the 2nd, and that would be y to the 6th. Same thing if they're dividing. Like, let's do this one. If I had x over y to the 3rd, all that to the 6th. Well, that x has a 1, so it'd be x to the 6th on top, and it'd be y to the 18 on bottom. And then the last thing you really need to know is anything to the 0 power is 1. Even if it's a lot of stuff. So if I had ab squared c to the 4th, all of that to the 0 power, it is 1. Anything to the 0 power is 1. So let's do some examples. Example 1, these are all multiplying, right? And the rule is if they're multiplying, you add them. So I'm going to add my x's. This x has a 1. So if I added all the x's, 1 plus 2 plus 3, that'd be x to the 6th. Same thing with my y. This y has a 1. So if I added all my y's, I would get y to the 3rd. Number 2, they're dividing. The rule is if they divide, you subtract. So if I subtract my x's, I would get x to the 5th, because 4 minus negative 1 is 5. If I subtract my y's, I would get negative 2. 3 minus 5 is negative 2. If I subtract my z's, I would get z to the 1st. Now, you cannot have a negative exponent. So to fix this problem, x to the 5th stays on top, y squared goes on bottom, and z is positive, we're going to leave it on top. You can put the exponent of a 1, but most of the time, they're not going to put an exponent of a 1. They're just going to assume that you know that. Number 3, there's a couple ways you could do it. You're going to combine these in the middle. In the middle, if you added those, you'd get y to the 3rd, and then it'd be to the 4th. And then 3 times 4 is 12. You could also multiply that, so you would get y to the 20th and y to the negative 8. And then again, you can add those and get y to the 12th. So it doesn't matter which way you do it, which step you do first, you'll still get the same answer. Number 4, that 2 on the outside is going to go to everything. So I'm going to put a 1 on my negative 2 and a 1 on my 5. So I'm going to multiply it to everything. So I get negative 2 to the 2nd, x to the 6th, y to the 2nd. See, I took that 2 and multiplied it to all 3. On bottom, I get 5 to the 2nd and x to the 14th. Then you'd have to do -2 squared is 4, x6, y2. 5 squared is 25, x 14. 4 over 25 will not reduce, but my x's I can subtract, so I have 4 over 25. When I subtract my x's, 6 minus 14, I get 8, -8. And then y squared, there's no y's to combine, so I'm going to leave y squared on top. Now you cannot have that -8, so I have 4 over 25. X to the 8th would move to the bottom, and then I would leave y squared on top. All right, let's do example 5. Anything to the 0 power cancels out, so I'm just going to leave that, mark that out. So multiply here, and I'm going to get x to the 6th. Multiply here and here, so I'm going to get x to the -8 and y to the 2nd. On bottom, I'm going to get x to the 6th and y to the -4. Now on top, I can combine these x's. -6 plus -8 is -2. So I have x -2, y2, and on bottom, x6, y -4. These are dividing, so we're going to subtract. -2 minus 6 is -8. And 4 minus -2 is 6. The only thing wrong with that is you can't have x to the -8. So y to the 6 stays on top, and x to the 8 goes on bottom. Okay. A monomial is a number, variable, or product with one or more variables, non-negative integer exponents. So a monomial, it just has one term, basically. The degree of the monomial is the sum of the exponents. So like this degree, we would add the exponents. We would do 4 plus 1 plus 5 and get 10. Same thing here. We do 1 plus 6 plus 1 and get 8. Here we get 1 plus 6 plus 1 plus 2, 7, and 10. A polynomial actually, you don't, this is not even included, so we're not even going to worry about this. This is the next lesson. All right, so you should be good to go. I know I threw a lot of rules at you, but it is review, so hopefully you remember some of it. If you need any help, call me over and I will help you.